Hello everyone, we are Team Shockwave and this is our pulley model designed to lift a platform. The model is designed by using the handle, pulley wheel, rod, platform, and supporting frame. The main components include the handle, pulley wheels, and rope. When the handle is rotating, the rod will move and transfer the motion to lift the platform upwards. To use the model, we simply apply a rotating force to the handle. As the handle turns, the rod moves over the wheel, causing the platform to rise or fall. By changing how fast we rotate the handle, we can control the velocity of the platform. With these simple setups, it allows us to clearly observe how motion can be occurs in a controlled and repeatable way.
The first physics concept that is integrated into our Pulley model is kinematics. Now, under kinematics, we will learn two things. The first one being how do motion changes form over time. Now, I have this handle at the back and I'm going to rotate it a couple of times. Okay, so when I'm rotating the handle, I'm applying force that creates rotational motion. Rotational motion from this handle is then transferred into the first mechanical coil. Now, as this mechanical coil is moving, rotational motion is transferred onto this rope over here. Now, this rope can only move in two ways. One is it can go to the left or it can go to the right. Now, this shows that the rotational motion that has been transferred onto the rope has been changed to linear motion. And when the rope is on a linear motion all the way to the second wheel, from linear motion it changes back into rotational motion. Now, from the second wheel all over to this platform. Now this platform, the same thing, it can move two ways only, which is up and down. So from the second mechanical coil, rotational motion is then changed back into linear motion. The second thing that we will learn under kinematics would be uniform motion. Now, I will rotate this handle at a steady rate. 1, 2, 3. When you rotate the handle at a steady rate, the velocity of the platform is constant. Constant velocity means that the platform is experiencing zero acceleration. However, it is important to note that there are two phases in which acceleration values of the platform is non-zero. The first phase is the time frame between a stationary platform and a moving one. For example, the platform is stationary. Now, if I rotate it, it will start to move. The initial velocity is zero and the final velocity is of positive value. This shows that the platform itself is experiencing positive acceleration. The second phase, however, occurs when the platform is moving and it is stalled. The initial velocity is of a positive value and the final velocity is zero. At this point, the platform experiences negative acceleration, or in other words, deceleration. The second physics concept that is integrated onto our Pulley model would be forces and torque. So it starts as the same way again. When I am applying force into the handle, I am applying a kind of force we call torque. Now, how do we know that the force applied is torque? It is because we are applying force in a rotational motion. Now, the formula for torque is T equals F being force and R being radius. So the higher your radius of the pulley is, the higher the torque that you can produce with this handle. last physics concept that is integrated onto our model would be principle of conservation of energy, which states that energy can't be destroyed nor created. It can only changes form. When I'm applying a force to the pulley handle, my thumb over here is applying mechanical energy. So as soon as the components of this model starts to move, like so, the mechanical energy which is from my thumb has been transferred or changes form into kinetic energy. Now, we all know that things that move or components that move in this case, they all contain kinetic energy. So from here onwards, all the way until here, it will be kinetic energy. Now, the last point will be on this platform, the hanging platform. Now, on this hanging platform, all those kinetic energy that you see will then change onto potential energy. Now, we all know that the formula for potential energy is PE equals mgh. However, for us to calculate the potential energy of this platform, we are using PE equals mh. Now, why do we not use G? So G stands for gravitational acceleration. Now, an object only experiences gravitational acceleration when it is free falling. In our case, the object, being the platform, it is not free falling. It is suspended by this thread, which means that G is not taken into account. That is why we calculated potential energy to be h. Now, there are some things that make this model not 100% accurate. There are two main factors. One being the internal friction between these components. So when I'm spinning the handle, as you can see, you can hear that there's a lot of friction going on within the components. So this is where some of the energy that we transfer will be dispersed, will be dissipated. So some energy along the way from here all the way until here, some of it will be dissipated into thermal energy due to internal friction between these components. The second factor that makes it not 100% accurate would be this string. So now this string, it is made out of rubber bands, and as we all know, rubber bands have elasticity, and anything that has elasticity has elastic potential energy. So when I am moving this handle, you can see that the rope is constantly being stretched all over the place. So some energy are then lost into EPE. Those are the three physics concepts that is integrated into our model that we all from the shockwave. Thank you.